to this first problem, the objective here is to find out how much round stock we need to buy to make this triangular shaped part. And the only information that is given here is, besides the notation that I wrote up here, what I wrote is buy round stock to make this part, and how much material needs to be removed off the sides. So the only information that's given as far as numbers is the 4 inches and 625 thousandths, which is 4 and 5/8. So what I do is, again, for me, mathematical is very visual. I have to kind of see it. There are a lot of people, well, not a lot, but there are some people that could just visualize it in their brain. Like that one kid that came a couple weeks ago, Cosmo, he's just a crazy smart kid. So here what we have here is 4 inches, 625 across the bottom, the base of this triangle. What I do is I put a dot pretty much the center of the triangle, and then I'll extend a couple of lines out. See if I can find a better marker here. Bam. That made a difference. So I extended this line out, then I bring this down and I make 2 right angles. What we have to know is that we have 3 points. The triangle has 3 points here. If we take those 3 points and we divide by 360, because we have a 360-degree circle, what do we have?
120.
That means that the distance from one point to another point is 120 degrees. Therefore, well, from right here to right here is 120 degrees. Half of that would be 60 degrees, right? And what do we know about right angles? If we have big B up here, which is part of the right angle, we also have big A, which equates to what?
30. Half of 60.
30 degrees. 30 degrees. Okay? Now, again, we got to kind of keep in mind what we're going after. What do we need? We need to buy material that is going to be the diameter of the outer extremity of this triangle. All right? So we just say this is X. That's what we're looking for. We're looking for X. What do we have to work with? Now that we split this into 2 right angles, we can simply take the 4 inches, 625 divided by 2, and that'll give us 2 inches, 312 thousandths and 5/10.
Yeah.
2.3125. So now we have this right angle here, and let's just pull it away from the picture here, make it a little less confusing. And we have this, the base of this angle is 2.3125. We also know that big A is 30 degrees and big B is 60 degrees, right?
Yeah.
What are we looking for here? We're actually looking for little c.
Yeah. B10.
Little c, which is the hypotenuse, fancy name for the longest part of this angle right here, is what we're looking for, because if we get that, that's really equates to the radius, distance between here and here. Okay? Yay? So we need a formula that is going to give us little c. Anybody tell me what that formula is?
Yeah.
What is it?
The B times the tangent.
All right, it's going to say little c equals what?
Then the B times tangent.
Anybody?
Tangent A.
So little c equals a squared plus b squared squared.
No. That's not, I'm not looking for little a. I'm looking for little c. Give me one that gives me directly to little c.
The B times tangent 30.
Okay. Little b times tangent big A. Yes?
Yep.
Little b times 10. No, that gives me little a. That's not gonna work.
Oh, you want the,
I want little c.
So the only formula I see is number 1. It says little c equals a squared plus b
No,
squared.
no, there's another one in there. And I don't happen to know what it is. Let me see.
Yeah, you're right.
No, I don't want that one. That gives me little a. I'm looking for little c.
Yeah,
Okay.
you take a B plus A, you hear
Little
the
c
C.
is b
Because
divided by
A-
Here it
b.
is. Here it is. I know that. I know that I can go that route. Here's one right here. Little c equals.
A cosine b. A divided by cosine b.
No, that's not gonna work either. Little a divided by, here it is. Little c equals little b divided by cosine big A.
Doesn't make sense.
No, it's not the same. I wanna go directly there. I don't wanna go by route of New York. In other words, I don't wanna have to take a long cut. I know that I could get there by figuring out little a, but then I have to do something else. I wanna get there directly. Little b divided by cosine big A gets me there directly. How do I do this? Well, I take little b, which is 2 inches, 3, 1, 2, 5, divided by what? 30 cos, you press that on your calculator, and then you hit equals. Will that get me there directly? Yes, without having to get little a. You understand? I mean, ultimately, I gotta get little a anyways, and I'll tell you why in a second, but. What's my answer?
2 inches, 670 down, 2/10.
All right, so my answer is 2 inches, 600,
670.
2 inches, 670,
2/10.
2/10, and how many millions?
4 million.
Okay, so we're gonna go with
2/10.
2/10, 40 millions. I'm gonna go ahead and put the 40 this time. Why am I doing that? Because we only round off to the fourth place back normally. But why am I doing this? Because I need to multiply that number by 2. And that's gonna give me a more accurate number on my diameter. All right? So why do I need to multiply this by 2? Because this answer right here is what?
Radius.
The radius of the circle, right?
Yeah,
Which, if I multiply this times 2,
you get the diameter.
gives me x, which is the diameter, right?
Yeah.
What's my answer?
5 inch, 340 down, 4/10.
5 inches, 340,
4/10.
and 4/10.
Yeah.
So you understand, in this case, I did keep the millions, because that number I knew was gonna be at least 8, which would have brought this number in the tens higher later on, you understand? But normally I round off to the fourth place back, but in this case I did because I'm gonna multiply it by 2. You understand what I mean?
Yes, sir.
All right, so, and if the number behind that was a 5, I would have made this a 5 or greater, and then that would have probably changed my,
Diameter.
you know, that would have changed it by maybe 1/10 or a 1,000th difference, who knows? I don't know. But there we are. All right, everybody track this? Everybody get this okay? Anybody that didn't get it? Well, okay. Yeah? All right, so there's one more thing that we need to figure out, and that would be the spaces, the amount of material that has to come off of each side, which is all this, and so on. In order to make this triangle, once we buy the stock, we gotta figure out what is the size between here and here, and we'll call that y. Okay? So how do we figure out y? Well, the distance from here to here, if we find this, we'll also find the distance from there to there. But how do we find this distance? Remember, when we have 30 degrees, what's the special rule? Divide that by 2. 1 inch, 335 thousandths, and 1/10. 1 inch, 3, 3, 5, 1. Yes? I just did it in my head, so please confirm.
Yeah.
Okay.
Yeah.
1 inch 335 thousandths and 1/10. Again, I divided this by 2 because these are what we call the special angle. 30. I coined them that, special angles, 45 degrees, 30 degrees. Why? Because they're used frequently in industry. And if you know more about this stuff, it's gonna help you to figure things out quicker, okay? So we're all good with this one? And by the way, so how much does Y equal? 1 inch, 335 thousandths, and 5/10. And 1/10. Okay, so that's how much material we're gonna have to remove off each side in order to get this triangular shape. It just so happens that this is the same as this. Okay? And how do you know that? How can you confirm that? Well, you take, what is the distance from here to here? You take the radius minus little a, and it winds up to be that. You understand? We're good. Okay, guys, welcome to my YouTube channel. Hopefully you had fun. We're doing shop math here. You guys are all supposed to go, yay, boo, yay, you know, give me the sound effects, no. That would be good, right? The whistle and the sound effects, no? Fine. All right, so we have problem number 2. We went through problem number 1 in session 1. And now we're gonna be going through problem number 2. Here, your boss comes up to you and says, I need 3 of these, or whatever. There are a couple of things that are missing in this sketch, or this drawing, okay? What's missing? Anybody? Audience participation will be great.
Between the side,
We're missing
the
the overall thickness of this part, right? Is that there?
Yeah,
So it's not there.
not there, yeah.
We can't go and start cutting material if we don't know how much to cut, right?
Yeah.
And so what do we gotta do? And what else is missing? Anything else is missing?
Not a side.
The angle.
There's an angle missing up here, right?
Yeah.
So there are a couple things missing here in order for us to go forward on this problem. How are we gonna go about this? Well, I'm gonna look at this and say, I think, okay, I have this. I can make a right angle out of this. Uh-oh. Can I? Wait. Let's see, let me try this a different way. So if I make a right angle, okay, here we go. All right, so we have, then I do this. That's better. So now I have two right angles. I have one here, and I have one here. And this is 65 degrees right there on tangent big B, right?
Yeah.
Or angle big B, because that could be cosine big B or sine big B, but we're just gonna say that that's right there, 65 degrees. We also have, what does this represent?
Little C.
Little b. If it was little c, it would run along the length of that, and then you would see it like this. You understand?
Oh, okay.
But it runs up and down, which indicates it's little b. So now we have a problem here, and I'm gonna go ahead and draw it over here. I don't know if the camera can catch that or not. And we know that this is 65 degrees, which makes this over here what?
25.
Very good. 25 degrees. We also have a height of this right angle of 4.5, right? What are we looking for here?
Little A.
We are looking for little a. The distance between here and here is essential. We need that. How do we get that? Little b, or I should say little a equals, and I'll go ahead and write the formula up here. Little a equals tangent big A times little b. Roger that? Little a equals tangent big A times little b. How do we do it with our calculators? We're gonna say 25. We're gonna press tan